Let us start with unit number 3, part 1, that is neural networks. Start with the introductory part. What is meant by a neural network? We are going to make the machine as intelligent in the way how it processes the data, which is inspired by the human brain or human being's brain. A neural network is a method in artificial intelligence that teaches the computers to process the data in a way such that it is inspired by the human brain. I told you earlier, artificial intelligence is a main area, machine learning is a sub area, and then deep learning, neural networking, image processing are parts. Examples of these components include handwritten recognition for check processing, that is CHEQUE. It is not a CHECK, it is a CHEQUE. Speech to text recognition, oil exploration data analysis, weather prediction, facial recognition, and so forth. See, neural networks may not handle not only a simple one, they can handle huge volumes of information at once. Neural networks can receive and process vast amounts of information at once, making them useful in image compression. As you know, image compression is nothing but a technique where we have without having a model, everything will be converted into reduction in the terms of image is said to be image compression. What are the applications of neural networking? Handwritten recognition, image compression, traveling salesman problem, stock exchange prediction. All these are some of the neural network applications. Unmanned system. See, I think nowadays we have a jet fighters without having any kind of human effort. A machine sensor or machine neural systems itself can manage robotics, IoT, internet of things, air force, transport control, pattern recognition, spacecraft, satellite, defense systems, and so forth. What are the elements in the neural networks? Here, this is the input layer, hidden layer 1, hidden layer 2, and output layer. So, input layer, it accepts inputs in several formats provided by the programmer or user. Input layer is a layer that accepts the input in different formats provided by a programmer. Hidden layer. Hidden layer is an intermediate layer in between input and output layers. It performs all the computations or calculations to find hidden patterns and features. Output layer. Output layer goes through a series of transformations using hidden layer, which finally results in output that is conveyed by using this layer. Whatever the formats of data given to the machine is said to be input layer. A intermediate layer which performs all intermediate or mediator mapping, all calculations to find hidden features and patterns is said to be hidden layer. And the series of transformations can be performed in the hidden layer will be produced to a output, what you call output layer. This is a diagram, very important diagram you have to draw in your examinations also. In other way, we can represent, as you know, we have two categories of variables. Number one is independent variable, second one is dependent variable. In the case of data warehousing also, we used to have this concept. For example, consider the student marks. Student marks related with marks in subject 1, subject 2, subject 3. These are independent variables. When you find total or a sum, that is said to be dependent variables. What is dependent? These are the variables which are dependent on a variable, what you call independent variables. So here input layer may take input independent variables. These are called as the neurons, axons. And here this is a hidden layer. Hidden layers may vary from structure to structure. It may have only one hidden layer or more number of hidden layers. Finally, we are producing what? Output layer called dependent variables. Next one is anatomy of neural networks. If you want to train a neural network, we have some set of objects. The same layers. What are the layers? Layers are combined into a network or a model. Second one is input data and corresponding targets. Loss function, which always defines a feedback signal used for learning. Optimizer, which determines how learning process is going on. So objects includes number one, layers. I told you what are the layers. Layers may be input, hidden or output, input data and corresponding target. What is target? Output. In between, there is a loss function which defines a feedback mechanism. Optimizer determines how learning proceeds. We can see this element in a diagram. A network composed of layers that are chained together map the input data into predictions. What is our final outcome? Our final outcome would be a outcome called a predictions. See this, we have input X, layer, data transformation. As you know, data will be converted into some other format is said to be a transformation. In the case of KDD of data mining and warehousing, we have data collection, data integration, data cleaning, data transformation, data mining, knowledge extraction, finally decision making. Like that, data transformation based upon weights, number of layers exist. I told you number of layers exist along with the weights. Here we have a predictions. Based upon your training model, we can produce predictions. This is a loss function, but final outcome would be optimizer. The loss function then compares these predictions to the target, producing a loss value. Loss value is nothing but measure of how well network predictions match what was expected. Whenever the loss function value or prediction value, both are expected and actual values are equal, then we can have best optimization. Optimizer uses this loss value to update network weights. The building blocks of deep learning. See, fundamental data structures in neural network is a layer. As we have seen in the previous one, there is input layer, hidden layer 1, hidden layer 2, and output layer. A layer is a data processing module that takes as input one or more tensors that outputs one or more tensors. What is a tensor? I told you. A tensor can be a generic structure that can be used for storing, representing, and changing data. See, whatever the content that is given to you in the terms of a bracket is a definition for particular technical term. Some layers may be stateless, but more frequent layers have a state. Layers weight one or more several tensors learned with stochastic. See, stochastic is nothing but random probability, gradient descent, which together contain a network's knowledge. There exist different types of layers for different tensor format and different types of data processing. We have a simple vector data stored in two-dimensional tensor of shape, samples, and features, often processed by densely connected layers or fully connected dense layers. In the case of dense class in Keras, sequential data stored in three-dimensional tensors of shape, samples, time steps, feature is typically processed by recurrent layers such as long short-term memory network LSTM layer. Image data stored in four-dimensional tensor usually processed by two-dimensional convolution layer. models, that is network of layers. I told you, deep learning model is a directed acyclic graph of layers, which consists of linear stack of layers, where we are going to map a single input to the single output. Some common types of network topologies or structures includes two-branch network, multi-head networks, inception blocks. Inception blocks. What a topology of network defines? A topology of a network defines hypothesis space. So we can define machine learning as searching for useful representations of some input data within predefined space of possibilities using guidance from a feedback signal. Guidance from a feedback signal. By choosing a network topology, you constrain your space of possibilities. Hypothesis space, I think in the case of machine learning, we usually uses a mechanism what you call capital H is a hypothesis space, small h is one particular hypothesis, to a specific tensor operations mapping input data into output data. Picking up the right network architecture is more important than the science, although there are some best practices and principles you have to depend on. Only practice can help you to become proper neural network architect. Loss function and optimizer. I told you in this diagram, we have a input, layer, data transformation, predictions, true target. Predictions and true targets are compared with the help of a loss function. Then we can get the loss code where we are giving optimizer. Based upon optimizer, we can modify the weights. So again, the same process will be continued in the terms of better outcome. So loss function, the quantity that will be minimized during training, quantity that will be minimized during training, it represents a measure of success for the task at hand, is said to be loss function. Optimizer, it is nothing but a stochastic gradient descent, SGD, determines how the network will be updated based on loss function. It implements a specific variant of stochastic gradient descent. Next one, neural network. Neural network has multiple outputs, may have multiple loss functions, one per output. But the gradient descent process must be based on a single scalar loss value. That is, so for multi-loss network, all losses are combined into scalar quantity. Choosing the right objective function for the right problem at the right time is important because fulfillment is very important for us, so that we are going to have a network that is end up with doing the things we may not have wanted. What is our target? It must do the things whatever we want. Fortunately, when it comes to a common problem such as classification, regression, sequence prediction, there are simple guidelines you can follow to choose the correct loss. Loss function is very important. See, here the concept is what is meant by neural networking. Sometimes, see, I'm always trying to give you the information in the terms of introductory, so that while writing any of the question related with a neural network, you can write all these points without losing. So you can have a maximum amount of vocabulary. So diagrams are very, very important. You have to draw this diagram clearly. So independent variable, dependent variable, anatomy, and the diagrammatic representation. Whenever we have a diagram, you are allowed to write on your own. Next one is Keras. I told you in a previous one, Keras, TensorFlow. These are neural network component frameworks. Keras is a high-level deep learning application API, application programming interface. It is a framework developed by Google for implementation of neural networks. I told you TensorFlow, Keras, PyTorch. It is written in Python language and it is used to make the implementations of neural networks easy. We are going to make the implementation of neural networks very simple. We are using Keras. It also supports multiple backend neural network calculations or computations, multiple backend neural network computation. See this, it is easy to use. It's more flexible. Here this is a TensorFlow and it is Keras, high level architecture API. Keras is a high-level deep learning application programming interface developed by Google for implementing neural networks. Now, Keras is a deep learning framework for Python that provides a convenient way to define and train almost any kind of deep learning models. So many of the researchers uses Keras for fast experimentations. Keras has some features. Keras allows the same code to run seamlessly on GPU or CPU, Central Processing Unit, Graphical Processing Unit. Keras has a feature of user friendliness. It is very easy to learn, easy to quickly design, prototype. Keras has built-in support for convolutional networks. It may be for computer vision, a recurrent network for sequence processing, or any combination of both. Keras supports arbitrary network architecture, multi-to input or multi-to output models, layer sharing, model sharing, and so forth. So Keras is distributed under MIT license, which means that it is open source. What is open source? Without having any kind of license, your project, you are allowed to use search Keras. It is compatibility with version of Python from 2.7 to 3.6. Keras is used at Google, Netflix, Uber, CERN, Help, Square, and hundreds of startups working on wide range of problems. Keras is also popular framework or Kaggle. It's a machine learning. I think it's a machine learning competition website where almost every recent deep learning competition has been won using Keras model. See, this is a TensorFlow, Keras, and other components framework. Google Web Search interest for deep learning framework over the time. See this is the Keras, TensorFlow, and Teno and CNTK. I told you Keras is a high-level library for providing building blocks for developing deep learning models. It does not have any kind of low-level operations such as tensor manipulations and differentiations, but it is completely depends on specialized, well-optimized tensor library, which serves as a backend engine of Keras. Keras handle the problems in modular way. What is modular? Partitional. Several different backend engines can be plugged seamlessly into Keras. That means many components are going to be connected together in order to integrate into the Keras. There are here three existing backend implementations: TensorFlow backend and Tino backend and Microsoft Cognitive Toolkit CNTK backend. See this? Deep learning software and hardware stack, Keras, TensorFlow, Tino, CNTK, and I told you Keras may be executed on either GPU or CPU. What these components are? These components are common the platforms for deep learning today. And then TensorFlow, Keras, all these are providing a faster, better way of writing the program code. Developing with Keras. Keras workflow look like the following manner. Defining your training data, input sensors and target sensors. And you need to define a network of layers which connects, which maps your input to the target, how input is mapped with the target. You need to configure, I told you in the case of previous one, neural networks, loss function, optimizer, and some metrics. Configure the learning process by choosing a loss function or optimizer or some metric to monitor. Iterate your training data by calling fit method of your model. What is the first point? Define your training data. What is it? Input tensor and target tensor. Define a network of layers which map your input into targets. Configure the learning process by choosing a loss function, optimizer, and some metrics to monitor. Iterate on your training data by calling the fit method of your model. There are two ways to define your model. Number one, sequential class. Second one is functional API. What is sequential class? Linear or a serial stack of layers is said to be sequential. Directed acyclic graph of layers which allow you to build completely arbitrary architecture called a functional API. So this learning process is created in compilation step where you can specify optimizer and loss function. I told you we are going to capture the predicted value and executed value in the terms of a loss function. Whenever loss function optimizer is going to change the weights, this process is going to be repeated. Finally, learning process consists of passing numpy array of input data numpy per array of input data to the model via a component via a fit method. See this? Training data, defining in the terms of mapping, configuring loss function optimizer other metrics, iterate the process. Next one is, next question. How to set up deep learning workstations? See, if you want to develop any kind of deep learning application, first you need to have is setting up your workstation. Although it is not strictly necessary, it is highly recommended. Although it is not necessary, you can run deep learning code on modern NVIDIA. That is, it is a GPU, graphics processing units, which are family of microprocessor, what you call it, IC, that provide unified architecture for both visual and parallel computing. Some applications such as image processing with convolution network and sequence processing with the recurrent neural network RNN will be incredibly slow on CPU, even a fast multi-core GPU. If you want to realistically to be run on CPU, you will generally see the speed increase by 5 or 10 by using a modern GPU. I think GPU, graphics processing unit, is the best choice for implementing a deep learning workstations. If you don't want to install GPU on your machine, you can may experience the same level of experience with the introduction or with the usage of cloud platforms. It may be Amazon Web Services, EC2 GPU instances. You are running the locally or a cloud, it is always advisable to use a Unix workstation. Unix workstation, although it's technically possible to use Keras on Windows as well. If you are a Windows user, for example, your operating system is a Windows, but the simple solution is everything running is to set up Ubuntu dual boot on your computer. See, if you switch on your computer, normally it's a displays Windows operating system. If you have dual operating system, you can choose either Windows or Ubuntu. It may seem like a hassle, but using Ubuntu will save you a lot of time and trouble in the long run. Note that in order to use Keras, you need to install TensorFlow or CNTK Jupyter Notebook. The preferred way to run deep learning experiments. How these experiments are going to be executed. Jupyter notebooks are a great way to run deep learning experiments, in particular many code examples in the case of our textbook. There is widely used in data science and machine learning communities. Jupyter Notebook is a file generated by a Jupyter Notebook app, which can edit in your browser. This is a component where you can edit. It mixes the ability to execute a Python code with the rich text editing capabilities for annotating what you're doing. A notebook also allows you to break up the long experiments into smaller pieces that can be executed independently, which makes development interactive. So we always used to have a Jupyter notebook. We always recommend using Jupyter notebook to get started with the Keras. Although that is not a requirement, even you may have Python script or run the code with an IDE, integrated development environment, such as PyCharm. Getting Keras running. In general, in practice, we recommend one of the following two options. If you start with the installation of everything from the scratch on a local Unix workstation, you can then run either local Jupyter notebook or a regular Python code base. Do this if you already have advanced or high-end GPU. Otherwise, use an official EC2 Deep Learning AMI www.aws https aws.amazon.com Amazon AI AMIS, and to run Keras experiments, ask Jupyter Notebook on EC2. Do this if you don't already have a GPU on your local machine. So some of the components. Running deep learning jobs in a cloud. Advantages and disadvantages. If you don't have GPU already, then we can use, if you don't already have a GPU that you can use for deep learning, then running deep learning experiments in the cloud is very simple. What is a cloud? I told you. See, cloud is nothing but anything you can access without installing or without maintaining on its own. Cloud is nothing but sharing of services, storage, network infrastructure, or anything on demanding services with the help of internet on a pay-per-use basis. So there is no need to buy any kind of hardware. You are going to pay for only the services what you are consuming. If you are using Jupyter Notebook, the experience of running in the cloud is no different from running locally. If you are serious about deep learning, it is always advisable to set up a local workstation with one or more GPUs. EC2 is a great way to get started. You could follow the code examples in our textbook entirely on EC2 GPU instances. So, but if you are going to be a power user of deep learning, get your own GPU if you want to make your complete. What is the best GPU for deep learning? I told you NVIDIA. It is only the graphics computing capability company that has invested heavily in deep learning so far. So modern deep learning framework can only run on these cards. In general, we always assume to have usage of those components directly with the help of those cards. The main steps to set up a deep learning workstations. First one is updating Linux system packages, installation of Python pip command. It is very basic command going to be used to install other components. Install BLAST basic linear algebra subprograms required for mathematical operations. HDF5 data frame installation to store hierarchical data. Installation of GraphViz to visualize a Keras model. CUDA and CUDN NVIDIA graphics driver installations, installations of TensorFlow as a backend of Keras, Keras installation, installation of Tino. It may be an optional component. It is an optional component. First, you need to update the Linux system packages. installation of Python PIP command, installation of a basic linear algebra program, HDFI data frame installation to store hierarchical data, installation of GraphWiz, CUDA, installation of TensorFlow, Keras installations, and then Trino. These are the main steps to set up a deep learning workstations. See, in this session, we have seen how to set up deep learning workstations. Very important question. Keras, anatomy of neural networking, and what is neural networking. Okay, very important question. You can expect any format of question from the Keras or setting of deep learning workstations. Okay, that's all.